400 years ago, Galileo kicked off a search to figure out exactly what the universe is made of. We've spent the centuries since peering down to the smallest possible distances, trying to find the absolute, indivisible building blocks of reality. All of that experimental work eventually converged on this. This daunting string of math is known as the Standard Model. It is a terrible name for something so extraordinary. This single framework accurately predicts the results of hundreds of thousands of experiments. By any measurable metric, it is the most successful scientific theory we have ever produced. But just staring at the math doesn't give you an intuition for how it actually works. To really understand how this machinery fits together, we need to wipe the slate clean, start with a completely empty void, and build the physical universe from scratch. The first ingredient we need to populate our void is matter. In the quantum realm, matter is made of particles called fermions. They obey one strict rule, known as the Pauli exclusion principle. No two fermions can occupy the exact same space at the same time. This chart shows the four foundational fermions: the electron, up and down quarks, forming our atoms, and the nearly massless neutrino. Nature then took that base collection and inexplicably made two heavier, highly unstable exact copies, like the muon and tau, that instantly decay. Yet, whether stable or unstable, all 12 of these matter particles behave according to the exact same mathematical rules, which were first written down by the physicist Paul Dirac in the 1920s. So we have the 12 building blocks of reality, but right now they are entirely useless. Without a way to interact, these particles would just drift through the dark, completely isolated. To animate our universe, we need the second major category of reality: bosons. These are force-carrying particles. Because they ignore the Pauli exclusion principle, they can stack on top of each other endlessly to mediate physical forces. The first force they generate is electromagnetism, which is carried by bosons we call photons. This force creates electric fields and drives the chemical properties of elements. Then we have the strong force. The gluon sticks quarks together by forming a physical flux tube. If you try to pull them apart, tension grows exponentially. This confinement binds quarks aggressively, so they never exist in isolation, forever trapped inside larger structures like protons. The third force operates on a totally different logic. The weak force is carried by W and Z bosons, and instead of binding things together, it forces particles to decay and literally change their identity. Through the weak force, a down quark can morph directly into an up quark. That single switch turns a neutron into a proton, and that precise decay process triggers the nuclear fusion that currently powers our sun. Bosons serve as the invisible communication network of our void. They take a static, frozen grid of matter and turn it into a dynamic engine of chemistry and starlight. But there is a massive mathematical contradiction in the universe we just built. If you look closely at the equations of the Standard Model, they explicitly prohibit any of these fundamental particles from having mass. Without mass, every single particle would be forced to travel endlessly at the speed of light. They would fly past each other far too fast to ever cluster together, making atomic cohesion impossible. To fix this structural bug, the universe relies on a background layer called the Higgs field, and its corresponding particle, the Higgs boson. The Higgs field permeates every inch of empty space. You can think of it like a cosmic molasses. As those light-speed fermions travel through it, they experience drag. That resistance is what endows them with mass, slowing them down enough to actually form complex matter. Physicists suspected this field existed for decades, but it remained entirely unproven until 2012, when we finally smashed protons together with enough energy to create a ripple in it, detecting the Higgs boson. Combine the structural fermions, the interacting bosons, and the mass-giving Higgs field, and our assembly is complete. We now have a flawlessly functional model of the visible universe. This grid displays the finalized taxonomy: 12 matter particles, 3 forces, and the Higgs. Together, they represent the undisputed, predictive pinnacle of human science. Except for one glaring flaw. Drop a pen and you immediately see the force that is entirely missing from this picture. The model has absolutely no place for gravity. We understand gravity on a scale of stars and galaxies, thanks to general relativity, but the math of the quantum world completely breaks down when you try to force those classical laws into a subatomic space. The equations also offer zero explanation for the invisible realms of dark matter and dark energy. This leaves us with a terrifying mathematical reality. Despite its pristine record in our laboratories, the Standard Model fails to account for 95% of the total mass and energy in the cosmos. Because the math is so consistently accurate, it hides the path forward. For modern physicists, this total lack of error has become its own kind of problem. Inside these high-energy colliders, scientists are searching for a single calculated failure. They are pushing these machines to their absolute limits, specifically to find an experiment the model cannot predict. Finding these anomalies is the only way to peel back the next layer of reality. We must look for the breaks in the math to finally reach a unified theory of everything.